7 o'clock yet. So yeah, I think you've brought the half of the Netherlands with you, because pretty much everyone is Dutch in this crowd, it seems, and up until now it's been Belgian and UK. But I don't know. I mean, I think the group is probably going to change over time to
No,
be a little
no,
bit.
no. We have hello from Sweden.
Well,
And where's the rest of the folks coming from? I would love to hear that myself. Hello there. Oh, the Swedish people are talking to each other now. I do recognize some names, but I guess most Dutch people had enough of me. Oh, yeah, look at this. Germany, Jordan, Schipluiden, which is in the Netherlands. Pretty close from here. Delft as well. North London. Nice. Paris. Wow. Noodorp, yeah. It's pretty close. Haarlem. Yeah, you're right. There's quite a lot of Dutchies here.
mm.
So they have to deal with my Dutch accent. But yeah.
Well, I mean, that was the thing, because I realised it was overwhelmingly either Belgian or Dutch, and I've probably had a lot of people wondering, why isn't this talk in Dutch? But just for ease. I actually made a post about this on our page about a month ago. So we've got, I mean, I'm not sure how many people are on the call from these locations, but we've got Belgium, Netherlands, Germany, Luxembourg, loads of places in the Americas, India, Russia, Ireland, Hungary, South Africa. It's a lot of people nowadays. I think
Yeah.
after this event will almost be 800, and we were 700 a few weeks ago. So it's growing quite quickly, which is quite exciting.
I wonder what happens when the whole pandemic is done or over, because everybody's so on the internet right now. Everything is online.
Mm.
A lot of web. I think you can practically attend a webinar every evening. There's probably something there.
Yeah. Well,
Some people probably do, but yeah.
Yeah. Well, yeah, it was because I joined the Arrows group in November, and it was my manager of my last company who introduced me to it, and it wasn't really until then that I realised there's a massive community who. So I mean, I know there's nothing better than going face to face and being in a busy conference hall, but a lot of people still had that thirst, and it's now borderless having Zoom and Teams. So hence why we've got people from all around the world joining us. So yeah, man, it's thank God for Zoom and Teams, I guess.
Yeah, fortunately
everything's
Teams.
on Zooms.
Yeah. All the professional stuff is on Teams. I hate it. It's an ugly tool, but the video conferencing capability is quite good. Chatting is not.
Yeah. You tweeted saying that they need to get a new UX designer.
Yeah, I like Slack. I like the keyboard. It's very intuitive. At least I'm opinionated here, but I like the UI, the big fonts, the clarity, like where the new messages are. Keyboard support is excellent. I'm a keyboard lover. So and Teams really sluggish. The whole UI refreshing, switching channels is sluggish. I don't know. Probably is getting used to. Wow. Yeah, look at this. Jan van Veldhuizen, he's actually listening to 3 or 4 press days a week. Wow.
Well, I see. You need to stay update with things, especially if you're in software where there's a new framework for JavaScript coming out every 5 minutes. You need to.
It is. See, we have Slack supporters. Yes. Painting on the screen. Yes, that's a nice feature. I've asked actually create a user voice for that, because every time I tweet about Teams, Microsoft responds like, yeah, you know what? You can go to user voice and, file an ID. Yeah, of course. Yes, I can do that. It's funny. It's actually quite funny to see what's going on in the chat. Malta. Yeah. Wow. Stockholm. Eindhoven. Eindhoven de gekste. It's a thing from Eindhoven. Yeah. That's nice.
Yeah. Well, I think we've got about 65 people on now. Because the event is recorded, I used to be that I let the sessions kind of fill up a little bit. But yeah, I mean, if you're ready to kind of kick off shortly, then
sure. Yep.
Yeah, so I'll just give you a quick introduction, and then I'll pass you the hosting abilities. I'll stop sharing my screen and let you do the same. But yeah, obviously, thanks everyone for coming. This is the 10th .NET to the Core event, which is it's cool because I mean we started this in August 2020, and I mean I didn't really know we would get to close to 800 members in this time. So as time goes on, we're kind of figuring out what we want to happen with the group, and yeah, I think over the next few months we'll see it kind of change a little bit. Of course, we'll still have a lot of talks like this, but behind the scenes, I've been having a lot of conversations with kind of mid to large scale enterprises about what have they done with .NET technologies. And though I can't kind of reveal anything quite yet, in the next few weeks, we'll be releasing an event with a UK-based fintech who are going to be telling us about how they moved from a monolithic architecture to a microservices architecture. So that could be quite cool. But yeah, that's kind of hush hush for now and for your ears at the moment. Yeah, thanks everyone who turned up. As I said, I think a lot of people here know Dennis already. I know you put out a few things on the socials, and pretty much everyone who's engaged with it seems to be in the crowd tonight. So thanks everyone for turning up. Because of that, obviously Dennis doesn't really need much of an introduction. So yeah, I'll at the end of the no, we won't. We won't. But yeah, obviously I have just announced my next event in the end of April with. So I'm going to mispronounce his name again, but with Dennis Vroegop.
Good enough. Yeah.
Good enough.
Dennis Vroegop.
Vroegop. Okay. Well, if I'm thinking about moving to the Netherlands, I need to figure that out quickly. But Dennis Vroegop, who's going to be talking to us about .NET Core, AI, and a Raspberry Pi. Of course, just have a look on the page if you want to know a little bit more about that. And yeah, that event's actually going to be sponsored by Manning Publications. So Manning, if you know about the MEEP series, put out books about different topics on software development. So if you attend that event, you get a discount code and one person gets a free book from that event. So that's always nice. But I'll shut up now. I'll give it over to Dennis, who will take things from here. And as he said, if you were here at the beginning, he's going to be answering questions which I'll read out throughout the session. So usually we kind of leave it to the end for Q&A, but if you have a question, put it in the chat box. I'll read it out and Dennis will jump in. So I'll hand over the abilities to Dennis, and yeah, everyone make sure that you're muted. Yeah, we'll let him get started. So cheers, guys.
Thank you, Luke. Thank you. Awesome. How to practice TDD without shooting yourself in the foot. I actually shot myself in the foot many times. So that's probably also the reason why I started creating this presentation. I should be able to share my screen. You just mentioned this, so let me at least put my slide deck there. You can see it. For some reason now I'm losing the capability. Yeah, this is better. Can I somehow hide this thing? Sorry, guys. I'm trying to figure out how to. I have not used Zoom yet. Probably this one. No. Should I remove it, Luke? No, can't hear me anymore. Okay. Let's continue. I'm somehow now cannot see anything anymore.
We can see the presentations.
Yes, it suddenly changed. Yeah. Okay. Cool. That's good. Yeah, you see the presentation. So my name is Dennis Doomen, or in Dutch, Dennis Doomen. Very difficult to pronounce. I work for a small consultancy firm in the Netherlands, somewhere between Amsterdam and The Hague. And as I just said, I definitely shot myself in the foot a couple of times. I've been, I would say, practicing TDD for almost 15 years. Now it's like, yeah, it's 15 years. And before that, I also started using unit testing. I think I'm in a profession for something like 24 years. I started at the beginning of 1997. So I might actually have it off by one error. 50, okay. Anyway, and yeah, TDD is maybe not even the most important part of it. It's more like that you make sure that you create unit tests. That's really what it's about. And this is what we're going to be talking about. I am going to explain a little bit like what I think about TDD and what it means to me, because there's also some pretty dogmatic visions about that, which I like to address. So yeah, who am I? As I just mentioned, I call myself a bit like the continuous improver because I'm always looking for new ways of doing my work, which can be about tools, methodologies, principles, architecture, everything that makes me more efficient. And that's also my motto. You can see my Twitter handle as well. I have a blog, and I really talk about many different things. You'll find blog entries about structuring a team or getting more efficient communication, but also about specific tools, especially in the .NET space. I have a couple of projects that I maintain, coding guidelines, which I've been maintaining for, I would say, 20 years. Yeah, definitely. Yeah. I have an open source library for creating event sourced applications. Maybe if you're in the .NET space, you've heard of something called Fluent Assertions, which I've been maintaining for 10 years already. And I think a couple of weeks ago, it crossed the 80 million downloads, which is nice. Fortunately, I don't get any money out of it. I should have actually figured a way to do that. I would have been rich. And another library called Chill. So maybe if you've seen that, maybe not, check it out. It's not that important. So let's start a little bit with the ideal automated unit test. And I put unit between brackets, which is not for nothing, because unit is, again, a term that has different meanings for different people. And again, I also have an opinion about that, obviously. So yeah, let's see. And it's an opinionated definition because, yeah, again, there's also many books have been written about unit testing and testing at all. So yeah, I'm going to share something. So what does it mean for me? A unit test or a test should be fast. 50 milliseconds, it's a bit arbitrary, I would say. At least it should be fast. Everybody agrees. What it means, what is fast enough, it's a bit subjective. Depends also on your code base. But yeah, I think everybody agrees that a unit test is fast. It should also run in memory. Yeah, that comes with the fact that it needs to be fast. If it doesn't run in memory, it's usually going to be pretty slow. It can be run in any order. Another thing that's really important. I don't know if you experienced that you've been using MS Test, if you're in the .NET space. And maybe it's good to also mention, like, is there anybody who's not in the .NET space? Let me know in the chat. I can see that in the corner of my eye. But in the beginning, Microsoft built tools that would allow you to create unit tests, but they would all run sequentially. Then when you start switching to more modern open source libraries like XUnit, things will run in parallel. And then suddenly things start to fail. Like, hey, why is this test failing? It's red. But then you run it again, it's green. You're like, huh, what? And then you start to run a group of tests. And then some fail, some don't. That's usually a signal that, yeah, you cannot run them in any order. What does that mean? Well, it means a couple of things. You should create tests that do not create any side effects. They don't create, as I like to say, collateral damage. They don't change state. They don't create files on disk. That kind of stuff, we should stay away from that because, yeah, it's only going to cause a lot of havoc. Yeah, somebody says the hell of his reference. I wonder if everybody recognized the movie. It has no static dependencies. What does that mean? Well, it should use static. It should not use singleton. It should preferably not even use concepts like, which exist in the .NET space, called thread static or async local, which are concepts to be able to share state across threads. Don't do that in your test. It's going to hurt you really, really bad. It has no IO bound dependencies. In other words, and I mentioned this before, it does not depend on files, does not depend on network, it does not depend on external services. Kind of an open door, I guess. And it can be run in parallel, obviously. Yeah, I mean, I don't know about you, but in the code bases I'm involved, it's quite common that about 40% of my code base is actually tests, and a lot of them need to be run. I mean, if I look at my own open source library, Fluent Assertions, I think it has about 16,000 unit tests to run. Of course, there's about 2.5 unique tests, but they also run against different frameworks. 16,000, that needs to complete fast. I don't want to wait 25 minutes to get feedback. And I know from reality that a lot of code bases, they get bigger, they're more complicated, there's more functionality, and at some point it gets really slow. So you don't want that. Then what about this unit and integration and API test? That's another thing that I see happening a lot. It is not something you have to choose between. Yes, unit tests are the fastest. They're probably the easiest ones to understand because they're pretty scoped. They're really disconnected from the rest. You can reason about them. You can usually read them really well. If you create bigger scope tests like component or integration tests, it's getting a bit more difficult. But there's more. You may have actually API tests, that spin up a little subsystem, and from your test you send HTTP requests, and you verify whether the system does what it's supposed to do. We have that a lot, especially with current popular architectures like single page applications, where majority of the code is in the front end. It's built in a React or a Vue or any other of the popular frameworks from the last 5 minutes. But then you have like a big backend system with APIs. Obviously, you want to test that. And then you have UI automation, because you have your front end is hopefully covered by test as well. I mean, we have Jest, we have what is the word? There's a couple of frameworks that you can use. Enzyme. There's a lot of capabilities. You can do snapshot testing to actually compare the HTML output or the visual representation. But in the end, you may also have some tests that directly interact with the browser. Maybe using something like Browser Stack, Nightwatch, Test Trail, whatever you want to use. Selenium, obviously, yes, which is very popular. And then it's the final part. It's the manual testing. So in my vision, those are all complementary. In no world you should make a decision like, hey, guys, we only invest in API testing, or we only invest in unit testing, and girls and anybody else. No, they're complementary. Sometimes, probably as I said, unit tests are the quickest to develop, easiest to understand, but they cover a certain part of the system. But you also want to have cross, all these units need to be tested together. All of that adds to this nice feeling of security that everything works as expected. Manual testing should be focused on unstructured testing. And this is what quality assurance engineers should be doing. They have a certain, I think, skill set that most developers don't have, and that's that they want to break the system. You want to use those people to try to break your system, by understanding how things are supposed to work. Everything else that you can predict, automate. But use the QA not for stupid manual testing. Use them to try to break your system with that unique mindset they have. And I can see some positive reactions in the chat. So I guess Rogier is a quality engineer, which is really good. Yeah, and that also means that we don't want to throw stuff over the wall. And by the way, yeah, I see Jafar mentioning chaos engineering. That's also a very nice way of doing it. Developers should automate tests. That's it. So what else? Test-driven development. What does that mean? And by the way, sorry to interrupt the session. I really would like to see if I can actually see you guys, because I don't see anybody now. I can only see the chat. I guess that's a limitation of Zoom or my lack of knowledge. That's a shame. Anyway, test-driven development. It is really not that special. I mean, unit testing, just being able to write unit tests that are easy to maintain, that follow some of the things I mentioned before, it's already a big thing. The only thing test-driven development adds to that is the fact that you kind of think from your test. You design your code driven by tests, but it's not a testing effort. It's more like a design thing. Remember Dan North once mentioned, like, somebody that the guy or the person that came up with the idea of calling it like that kind of made a mistake. It's really about driving your system guided by tests. And there's a great book about it. I think it's even called like Behavior-Driven Development Guided by Tests. It's a pretty old book that talks about that. But let me share a little bit how I look at this. So the first thing, unlike many books tell you, is design class responsibilities. That's what you start with. Nobody in his right mind is going to start creating a test without having any other thing to execute. You typically first start to design the classes and how they work together, the responsibilities. And you think about it, you experiment a bit. It doesn't come out thin air. It's not like, hey, I'm going to create a test. Yeah, but for what? Did you actually think about the boundaries in your system? Which class is supposed to do what? You think about some of the solid principles. That's all part of that. So this is what I start with. Only then I start to think about writing my first test. However, and it's quite often that I do that, I actually start with implementing some logic, to to verify that the responsibilities of my classes or the modules, if you think about in the JavaScript world and TypeScript world, you think more about functions or modules and components. You start to think about the responsibilities, and you still also start to code a little bit. You may actually get something working before you write your first unit test, and that's fine because it's an iterative process. Coding is a what do you call that? It's a creative thing. Software development is a creative process. It's not factory work or anything like that. So it's perfectly fine to start building some prototyping code and then switch to a more test first mindset. That's when you start to write your unit test. And then the more traditional red green refactor thing will kick in. In this case, it means we write the first unit test. We may generate some stops. If your IDE supports that, it's usually quite easy to work with. Then you make sure that if they fail for the right reason. That's also important. Nothing is more awful than a test that succeeds, and then you discover it didn't even test what I was supposed to. That's why I want to make sure, let it fail for the right reason, and then, make it green. Somebody says, like, I call the pragmatic approach. Yeah, that's actually what it means, being pragmatic. And then, of course, yeah, you start to implement the real deal behind the tests, and you make sure that the test succeeds. And then you start to think about the alternative scenarios. This part is what I value the most when I do TDD, because I start to write a test case. And while I do that, my brain starts to somehow come up with alternative scenarios. And then what I typically do is literally write like dash / to do, write out, spell out in more functional descriptions, alternative scenarios. And that list will grow really quickly. And I'll just let it there, finish my test, and then start to implement the rest. This thing of writing your test and making you think about other scenarios is what's so valuable about it. You start to think about, hey, I just passed in a string. What if I now pass in nil as an example? Or what if somebody calls the other method first? Is that a valid thing? That's what I'm trying to do. Don't be dogmatic about it. Don't start to do what the book tells you to do. That don't. It doesn't work. And then I repeat this twice at least. So I create more tests. I don't refactor the underlying code, and then start refactoring. That's when you do, and then the whole cycle continues or repeats itself. So it's not like write a test, refactor, write a test, let it fail, make it green, refactor. No, it doesn't work. You should not refactor until you've seen a pattern. And I often refer to people I work with with the rule of three. I often say, like, seeing something twice, the same thing twice, is coincidence. Seeing that thing 3 times might be a pattern. So don't try to optimize and refactor things before you've actually identified the pattern. That's really important. And this is kind of what, for me, is test-driven development. It's more like a design process, but in the end, it's about designing your class correctly, thinking about the responsibilities, separating concerns, high cohesion, decreasing the coupling, and writing tests around that. If this code is done, if it put it in production, and a bug is detected, because we have a great, and we happen to have 2 really great QAs. If those QAs actually find a bug because they try to kill your system, I see that as a lack of specification or a lack of testing. So I'd first try to create a test to make sure that I can reproduce the bug. Make sure it fails for the right reason, and then implement the implementation and make sure the test is green. One of the beauties of doing it like that is also that your test can actually become more like functional documentation of what a class or a group of classes, and we talk about unit in a couple of minutes, are doing together. This is also why I often postfix my test classes with specs to emphasize to me these are just specifications of what I'm testing. Right. Let me see. Some people say, yeah, I think of BDD before TDD, behavior-driven development. It's a way of doing that. Yeah, yeah. Solid principles always apply there as well. So what's next? The principles of great tests. Again, all very opinionated. You should test against the observable behavior. Don't test internal state. Don't touch the internals of a system. Look at the class or the unit of classes and try to test that again. So for instance, if you have a module that exposes an HTTP endpoint, try to test against that. And I'll show you in a couple of minutes how I do that. But don't look at anything. Don't make things like private fields public or add methods that you can look inside a module. Don't do that. Only look at look at the public methods or properties that a component is supposed to expose. I would typically not even access the database if you build bigger tests where you actually include the database. It's an integration test. Only the observable behavior, because the idea is that if you rewrite your code, you should not have to rewrite your tests. If that happens a lot, that you have to rewrite your test, you probably tested too small, or your tests have too much intimate knowledge about the implementation. I used to call this do gray box testing, not black box testing, not white box testing, but gray box testing. But you can probably summarize it at looking at the observable behavior. Test at the right scope. It's also really important. And this is what we're going to cover separately in a couple of minutes as well. The right scope. Don't test too small. Don't test too big. And that's very difficult, by the way. In your test, if something is not important for that test, try to hide it from the test case. If something is important, make sure you show it. And this is something that you need to decide on per test case. I don't know if anybody reference or knows who the guy is in the background, but if you listen to its song, Move Your Ass or Hyper Hyper, I don't exactly remember which one, there's actually a statement that sounds exactly like what I just said. That's why some of my older colleagues call me the, yes, respect the man in the ice cream pan. Happy to see that the listeners recognize this. But this is a rule that well, you could say heuristic, but I think it's more like a rule that I use a lot during code reviews. If there's stuff in my test that doesn't belong there, I remove it. It should be hidden. But if you hide too much, you end up having a test that does not clearly clarify what it's supposed to do. So the rule goes both ways. Remember that. Crystal clear cause and effect. I would really love to be able to understand, like, this is the starting position, this is what the test tries to do, this is the act, and this is what the expected output is. That should be really, I don't want to scroll up and down all the time to understand, like, okay, where does this setting or this value or this piece of test fixture come from? I should be able to read my test from top to bottom without understanding anything else. Really hope that you can make that possible. And I'll show you, I try to demonstrate some examples where I try to do that. And it should read like a book, which is kind of the consequence of what I just said. I want to be able to read my code from top to bottom. By the way, for me, that also applies to any code I write. I love to read it as a book. Not like, I don't know, the 3 pieces of Lord of the Rings, because they're quite big, but something, more easy to grasp. For instance, don't try to compare it with domain-driven design, because that's a really big book. It's a great book, but it's really difficult to get through. Copy 2 times before refactoring. That's interesting. I'm a big proponent of applying dry, don't repeat yourself. But with testing, I'm really conservative. Even though 2 tests may look the same, they may not be the same. They may not be testing the same thing. So keep that in mind. Dry is something you should try to avoid as much as possible when grading tests. And it's really difficult. I know so many developers love to create private methods or base classes to move stuff that looks like, hey, I'm repeating myself, I need to put it in a base class. Don't. Only do it when you're convinced that the pieces that you want to extract really are not important for that test case. If they are, just duplicate the code. It's fine. And there's a couple of patterns that you can use for that. I'll show you that as well. And don't be afraid to use faking libraries. I know there's a whole, like, almost a holy war. Like, you have people that never use fake libraries, mocking libraries. You have people that love to use them everywhere. It is just bits and pieces. Sometimes a tool is applicable, sometimes it's not. It's just a matter of understanding when it's useful. I've worked with developers that love to test every individual class independently. And what they do, they slap on an interface, use a faking library to replace that that interface with a temporary stub or fake or mock. Terminology is not that important. And then you end up with unit tests that start with like building up 4 or 5 fakes just to be able to test something. That's probably a sign that you're testing too small. There's a question. A question is, who are you testing for? What's the purpose? Helps prove to your client. What about overhead of writing testing? Oh, these are questions that we probably should try to address later on. Yeah. All right. So what about that unit? And by the way, the questions that are not directly related to the slide, hopefully Luke will keep track of them so that we can also answer them. Maybe have a, yeah.
I was just going to say I'm making a note of them, so
yeah.
We'll do those later.
Awesome. So what about the unit? Yeah, that's a good one. Some people believe that the unit should be a class. I have a different opinion. I think, and you'll find that with everything I say, sometimes it's a class, sometimes it's not. There's no one way of doing it. As an example, you can probably not see my mouse, I'm not 100% sure, but this is a piece of code that is part of my Fluent Assertions library. And what you see here is that I'm saying that some kind of property, a field called event monitor has a property called occurred events. And I'm ensuring that this collection of occurred events is equivalent to this collection of 2 objects. And the only thing I care about, cool, you can see the mouse, that's nice, thank you. The only thing I care about is that there's 2 options of 2 objects in this collection. And those 2 objects should have property event name, timestamp, UTC, parameters with those values. I don't care about the order. I don't care about all the other properties. I only care about what you see here. And this ties back to what I said earlier. I like to only verify the things in my test which are important for that test case. So, and it's not really about the test case, but it's more about this little method be equivalent to needs to understand a lot of things. It needs to understand how to compare collections and whether the ordering is important. It needs to be able to compare types with properties with, in this case, anonymous types with a limited set of properties. It also needs to understand how to compare strings and how to compare timestamps and datetimes, and it even needs to understand dictionaries, for instance. So this little be equivalent to method is a pretty powerful thing. Now the question is, do I actually test this thing itself by testing the underlying structure? Well, this picture kind of it's a UML diagram. It's an ancient art that we used to learn like 25 years ago, 30 years ago, which nobody uses. You know, people just draw stuff. Well, we all work from home, so we don't draw at all. But this is kind of the implementation underneath it. You know, this is the main class, the equivalency validator, and it uses a bunch of options, you know, to be able so you can configure that. And it uses like a collection of, it's kind of a strategy pattern. I'm making a joke, by the way. I still use UML, but not as much anymore. Class diagrams, yes, but all the other ones, not that much. But this thing relies on an abstraction, the I equivalency step, and it has lots of different implementations. This is just a subset of it. And then there's a bunch of other options and decorators and things you can override and implement. There's a lot of stuff behind it. Now, if I would dogmatically, you know, do test-driven development as the books suggest, I would probably start testing individual classes. You know, this, or maybe this one. You know, I would create a test called complex type equivalency step specs, because I call them steps. You know, or maybe these options, because there's tons of options there. You know, like that. Or this one even, every interface separately. No, I don't. This is the scope of my test. This is my unit, because testing this be equivalent method, all of this I see as an implementation detail. So I don't want to test. In fact, if I go back in time, 10 years ago, when I started building this library together with my colleague Martin Obdam, there was only one class, the equivalency validator. The rest didn't exist. The rest evolved over time by refactoring, by applying some of the solid principles, you know, applying patterns. Look, the design patterns actually, you don't design using patterns, you design towards patterns. You start to refactor your code to use some of the patterns that exist because it makes it clearer to people what to expect. So I test the whole thing together. This is my unit. And if I go back to the previous slide, I also test like this. I test this B equivalent by actually using it in my tests and, passing in different parameters to see how it reacts and if it reacts correctly. And sometimes then I use a code coverage tool to figure out, did I actually properly cover everything? Because over the years, I've accepted pull requests, and it's not always evident that everything is being covered. I don't use anything like SonarQube in my open source projects. So my code coverage tool is not like to prove certain things. It's more like, it's a thermometer to give me a feeling like, how well did I actually design my code? How well did I make it testable? And that's one of the advantages of TDD. If you practice TDD, you'll figure out, unless you're already very experienced, that your code will be covered by a lot of more tests. It's designed for that. Oh yeah, somebody's asking, did you say don't use mock stubs or fakes? No, I didn't say that. What I said is use it when it actually adds value. And what you will discover, if you start doing things like this, testing at a bigger scope, you need them less. And that's the whole point. Sometimes you need them. If you actually have multiple boundaries within your system and you test your units, your boundary becomes a unit, and your unit depends on other services, other parts of the system, there is an interface between them. And then using a mocking stub or fake makes sense. But it's not like always use mocks or stubs or never use. Just use whatever works for you in the right situation. Use the right tool for the right job at the right time. Somebody really said recently on Twitter, which I support. Here's another example. I have an app, and this app calls commands or sends commands on to something called a command handler, which is a domain concept, and the green part is the domain. That invokes something on a domain model, and then the domain model stores events in something what we call an event store, which eventually ends up in an event database. Okay. Now, then we have something like an HTTP API, which is being used by the app because obviously the app is built in whatever framework is popular today, and it executes queries to get results. What we have here is that because event sourcing and of event store, so events cannot actually be queried. So what we have something like an event store and a projector that takes a group of events and tries to take those more functional events, projects them into what we call a projection. Anybody knows what architecture style this is? CQRS. It's actually, yes, CQRS, yes, and event sourcing. It's actually two different architecture styles. What you see here is command query responsibility segregation. So saying that we kind of acknowledge the fact that the command side of a system is often governed by different rules and constraints than the query side, the read side. That's why you see that the left side is the read side. The right side is the write side. I cannot even pronounce the difference. And we use event sourcing as a way to persist the events in the underlying database. And since an event store is kind of a big, long table, pretty flat, we need something to take those functional events and project them in a structure that you can query. That's what projectors do. You get a bunch of functional events, produce a projection, and then we store them, in this case, with RavenDB, which is a NoSQL solution in the .NET space, on in the read data. And maybe if people can let me know what platforms they use, also helps me understand my audience, which I asked before, but that would be nice. So the question now is, how would you test this? Would you test maybe just the API? That's a unit. You could do that, by the way. It's perfectly okay. Or you test the projectors and projections together. That's also an option, by the way, because they're usually pretty simple classes, and you can create an instance of your projector, which is your subject in the test. You pass in or you apply a couple of events, which in .NET code is pretty clean code, and you verify that the projection class is updated. or you test this whole thing. And this is what I often do. I'm going to write an article about this pretty soon for the event store people. But I actually take a big scope, and you would say like, but this is not a unit test because you also have like databases there, RavenDB and everything. I said, yes, you're right. You're probably right. It's not really a unit test, but I still decide to test it as a unit because it works for me. And I'll show you a little bit what that could look like. So show me some code indeed. So this is the starting piece of some code, and I'll switch to my IEE soon. What you see here is a test, and you see a bit of the design of that, the test fixture, the unit test. So let's see what's here. We start with a memory store, a in-memory event store. It's there. So in this test, we actually build up a real event store implementation. It just doesn't actually connect to a real database like SQL Server or something else. It's just an in-memory event store, but it works exactly like the real one. You can write events to it. You can query for events related to a particular domain object. It's perfectly fine. Then the next statement is we build the RavenDB database. That's interesting because now in my test, I'm actually creating an in-memory RavenDB database. And that's what I love about RavenDB. It's a NoSQL database that can run against a file system, but it can also run in memory. And it behaves exactly the same. Constraints, indexes, reads, writes, all the transactional behavior is exactly the same. That's beautiful because it means I can test all the way until the data layer without touching the data, without touching a file system. That's what this thing is doing. Now the rest, this big chunk of code. It's a bit more complicated to read. It was much nicer with the earlier version of .NET Framework, but with .NET Core, they redesigned the whole structure of how you build up your ASP.NET HTTP APIs. But the gist of it is that I'm actually doing this. I'm building in my test fixture an actual HTTP endpoint in memory again. There's no network layer here involved. That sets up the projectors, the projections, connects it with RavenDB, and connects it with this memory store. That's also why you see, and I'm using a little library called add services from. It's not something which is built in .NET, but the example code, I'll share the link afterwards. You can look at that. But it actually connects everything together. Connects it with the RavenDB database. It connects it with the actual in-memory event store, and it starts an endpoint. So I can really, from my unit test here, send HTTP request with all the headers and everything, and I get a real response back. Now, what's the next step? The next step is this piece of code. And this is, by the way, one unit test. So I'll probably see people frown about that. This is the first part. Setting up, and the first line should have been removed, just setting up some test data, some defaults or some things that I want to use, like a document number, country name, kind, because this is a bit of a domain about documents and legal documents. Okay, that's not really visible. Then this part, what I'm doing here is writing from my test directly into the underlying database. So I'm actually writing, in this case, some country record, and I'm writing something called a document count projection, which is something that tracks for a certain document, a certain country code, that it exists. Somebody's asking, what's the reason for singleton there for testing there, please? Yes, it's a testing thing. But it's actually completely safe and works really safe also on multiple tests. So that's okay. Yes, okay. So I'm actually writing some test data in the underlying database. Then I'm actually doing what's the act. I'm really writing an event in this event store, a state transition thing, which is a pretty crappy name for a functional domain. But this is what happens. This legal document has a state change, and I'm doing it. I'm making it active. Where this new state is here at the top. Oh yeah, I have to go up. New state is active. Okay, so that's what it does. It actually activates the document. What happens? Your unit test writes an event in this in-memory event store. This is being picked up by the projector. The projector, updates the projection, which is being written in the underlying event store. And then the last part happens. I'm actually creating an HTTP client, or in .NET space, a thing that connects it to the actual endpoint. You can even see the URL, statistics/metrics, country codes, and then I'm doing all kinds of noise here, noisy stuff, verify that the status code is okay, and then doing all kinds of assertions. So what happens? I'm actually doing the HTTP request, all in a unit test. Makes sense. I'm now going to close the door because it's very cold here. Just a sec. Which is going to be very funny since this is recorded. Maybe Luke can cut it. I see some people say test containers. I don't exactly remember what that was. Something with test fixtures, I guess. And somebody's making a joke about Fluent Assertions. Don't worry, we'll get there at some point. Yeah. So let's go to the IDE and look at the details. Where's my IDE? Here. This is the same test, with this very nice functional name. It's called when a state transition event is applied to a document count projection, the controller should return one active document. That's a very functional name, right? And the rest you've seen, there's a lot of code here. Does it fit on one screen? No, but of course I can do something like this, and now it fits on one screen. I'm pretty sure that you folks cannot read this anymore. I can still read it, but it's a bit small, yeah, which kind of defies the purpose. I have quite a lot of issues. So let's start. No, actually, just imagine if I would not have given you this like visual representation of this test, you probably would not have seen what's the range part, what's the act part, and what's the assertion part. So I have a better version of that, which is this version. It's the same. The only difference is I've added these arrange comments here, and here's the act, and there's the assert. It doesn't really help, right? So let's look at other things. Let's look at the name. We can probably get a better name here. When a document is activated, it should be included in the active count. So this thing is actually about counts. So let me see, is there an active thing? Probably here, yeah, it's the new state, which is active. So we're actually using this event to activate a legal document. Okay, and what do we do here? So we do the request, and then we get some data, and the country should match this country code. The country name should match the country name. Where's the country name? Oh, it's there, Netherlands. Okay. The kind, and apparently 1. So that's about what we really want to do. Let me see, there's questions. Do we really need all that work because it's testing the framework itself, it seems? Actually, it's not. It's testing functionally. Yeah. If you're writing automated functional tests with interact with deployed API in a real database, what's the advantage of such a complex unit test? Yeah, so that's a good question. Why am I actually testing such a big scope? Because everything inside this box, if I go to the picture, everything that happens inside that, it's an implementation detail for me. And if you use event sourcing, the implementation might change over time. You might discover that the way you project events into this RavenDB is going to change because of performance reasons or because the need changes. And then you want to be able to refactor the internal. So that is actually a reason. By the way, it's just an example. Again, you don't need to do it that complicated. I'm just trying to illustrate what I'm going to do to make this test more readable, because this is the crux. TDD is about trying to do things first, design your code using tests, write the test first to a certain extent. But what really keeps you out of the problems is making sure your tests have the right scope, are easy to maintain, have clear intention, and fail for the right reasons. That's what keeps you from shooting yourself in the foot, not TDD. Just what a lot of people do wrong is they practice TDD and end up with a lot of small tests, a lot of badly scoped tests, and also badly scoped tests and difficult to read. Somebody's asking, like, do you really connect to a RavenDB server in a test? No, it's all in memory. So this entire thing, go back here, it's at the top here. This actually creates an in-memory RavenDB database that works exactly as the real one in production. Any resources? Yes, you can actually go to my code and see how it works. Yeah. Okay, so I have to act in a range there, so it helps me a bit better to understand what's going on. But there's so much plumbing in this test. And what I don't like is that I have to scroll up and down just to understand, okay, what's this country one? Because this test will probably fail saying something like expected country, because with assert equal, the first parameter is the country, expected Netherlands, and found something else or something like that. It's not always important, but here, country code and kind, I like to see what's going on there. So I kind of stay away from constants in my tests. So what I prefer to do is actually just use Netherlands here. And I use filming here. And my document number is 1, 2, 3, because and this is personal. I think it's clear enough that it says Netherlands and that it says filming and that the code is 1, 2, 3. So I prefer not to use any constants in my test, with the exception of, where is it? The country code, because it happens to be GUID, and GUIDs are difficult to maintain. So yeah, I suck at remembering GUIDs by heart. So that one I do use a variable, a local variable. But for the rest, I just use the constants here. It's clean enough for me. Now, look at this stuff. There's a lot of stuff happening here, which I don't care about. But I really want to be able to test what happens if an event is pushed here, what the projector is doing, how it's written, and then what the HTTP response is going to look like. What's the JSON going to look like? What are the headers that are being returned, like caching headers, e-tags, that kind of stuff. That's actually part of the work of this little building block, this unit. And I want to verify that's correct. So I use test data builders. What happens if I do that? Now I replace the entire RavenDB thing with something called a RavenDB store document store builder .build. And I have a country lookup builder with a kind of Fluent API that allows me to specify what are the relevant parts of a country lookup. The beauty about this design pattern is called test data builder. The whole idea is if I call country lookup builder.build, like just this, it should give me a functionally correct thing. And it helps me focus on, show the things in this test that I really care about. In this case, I care about that this country is identified by this code. It's called Netherlands. I don't care about anything else. I also care about this projection, and it needs to have a specific number because it's important for this test. It needs to be in this country of this kind, and the rest. Here, I've actually built, if you look at the previous version, this whole chunk of code is not important for this test. So I've created my own little test data builder where saying it should use my document store because that's important. It should use this event store, and it should work with some kind of module registry, which is a bit of test framework that I've built. And this statistics module is really the production code that encapsulates everything which is needed to make sure that my HTTP endpoint is working. It connects to the projector and the projections. So removing noise, because now this is my range, this is my act, the rest is not really changed. Now, sometimes I don't really like this AAA syntax. So one way of doing that is rewrite it as this. It's using a little library called Chill, which is initially designed by an old colleague of me. I've took it over, which gives me this given when then. And now we enter the era of BDD, not pure BDD, because we're not talking with business people, but trying to emphasize more functionally. And now what you see is when a document is activated, given this memory store, given this RavenDB store, given this thing that happens here, we write some test data, go back to the picture, we write some test data in this database here. That's happening here. I still have all this knowledge. I use the host, and now I have a when, which is completely separate. And now it says, use the, the memory event store, write this event. So there's this little syntactical thing, which is called the, which allows you to refer back to things that you set up in your range. And then here the same thing. using the host, get a test client, and you refer to these elements. It's just syntactical sugar because the only thing it does is cleaning up, or at the end, that this host is also disposed, which is really important. In the meantime, let me see. So there were some questions. Would tests of this nature with a lot of setup run fast? Yes, that's the beauty of it. RavenBee can run pretty fast. I don't know if it guarantees 50 milliseconds because it's pretty fast, but it's really, really fast. Again, I'm not saying that you should always create tests like that. It could mean that you have a group of tests that work at this scope, but there's other parts of the system which have a much smaller scope. That's perfectly okay. It's up to you. A good thing to not just use domain enums constants. Tests should break when you change these. That's another good example. Why I, for example, somebody says like, let's imagine, you probably noticed that I'm doing this HTTP response or request, and then I manually parse this JSON into some kind of JSON object. I use JSON, the Newtonsoft JSON for this, and I explicitly test what the JSON will look like. I could also try to deserialize the response back into the .NET object that is being used by the underlying code to generate the JSON. But then I'm saying I'm actually comparing the production code with the production code. I'm testing a contract here. So if anything on the production code is changed, I want my test to fail, at least if I change something that is part of the contract. I don't want my test to fail if, for instance, I redesign the whole structure here. But if something in this HTTP response code changes, the test should fail. Some people say, yeah, but it's really nice to use the same object here in unit test that is also being used here to build the JSON output, because then if you change it, your test will not break, but it should fail. I mean, this is the contract. This module has a contract, which is the HTTP API. It should fail if I change it, even accidentally. So that's the reason why I'm really adamant about testing the contract. What are your views on something like AutoFixture to build test data instances? AutoFixture is also a nice tool for that. You can do that, especially if you feel like, this stuff is not relevant. You can even build a test data builder, and I'll show you what it looks like. This is test data builder. It's a Fluent API. It has some suitable defaults here for things, and this thing just happens to have only two properties, code and name. The code is generated, the name is generated with a GUID as well. You could use AutoFixture here as well. That's perfectly fine. And then you use things like identified by to override what is being generated. So this is definitely a place for something like AutoFixture. We use shouldly to just test the entire JSON response and make managing that easier, which has worked well. Yeah, that's also a good way. I mean, I'm using plain old MS test assertions, which, don't work really well. Anyway, yeah, and somebody says like, I used to use it chill, but I'm not seeing active contribution. That's correct because it's done. It's only supposed to solve a specific thing, and chill is not supposed to solve any other problems. That's probably why. But I can respond to that separately. Now, let me look at the assertions. This is interesting. What did I just do? Look at this. So I'm still calling the HTTP request, but now I'm doing something like, hey, I have this expectation, and the expectation needs to look like a JSON object that has a country with this code, a name, a kind, state, and account should be one. And in this case, I'm using something like deserialize anonymous type. And what it does, it tries to take this JSON body, which is a string, obviously, and then tries to deserialize that body into this type, into a type that has this structure. So what I get back is an object that looks exactly like this thing with these properties, but those properties are initialized with the values from the JSON thing. And now I'm using Fluent Assertions be equivalent to say my counters object that I got back should match this thing. And it doesn't matter what the actual type is, it just needs to match. It needs to be an object that has these 5 properties with those values. Any other properties that it has, I don't care about that. That's an interesting improvement. The rest is kind of the same, still the same. Now let's go further. I already said before, like don't apply dry to dogmatically, Be careful with it. Sometimes you want to. In this case, what I've done is I moved most of the plumbing into a base class, which is called given an HTTP controller talking to an in-memory event store. So I moved everything which is not important and which I'm sure which should not actually be reused. Things which I'm 100% sure that I never want to show in my test, I put them in a base class. So now, if I look at the test, it's called when a document is activated. That's it. That's just a given. Given the test data, when I write this event, this is the response. It's getting more functional now. You can see that. By the way, obviously, I don't use Shootly. I use Fluent Assertions, but yeah. Now, there's one problem. You remember that I'm actually still writing directly in this RavenDB. So I'm actually going through the back using a backdoor by writing directly into the database. It's an in-memory database, fine, but I'm still doing that. I don't really like that because, yeah, I'm actually not looking at the observable behavior of this thing. Yes, I'm looking at the HTTP API, but I'm not actually simulating what happens in real life. In production, the domain will not actually write data in this database. It will push, there will be a stream of events that go through this store and project it a certain way. So I don't want to do this anymore. So I did that in a different way. I rewrote my test that in my given, instead of doing this here, writing directly in the database, I'm actually simulating what happens normally to get to the starting state. I'm actually writing events in the event store. The country was registered. A contract was negotiated with this number, and the initial state is draft. The validity period was planned. So this contract is supposed to be valid for a certain period. And then this contract is approved for a certain period. It's still not active, but it's approved that it should happen daytime now at 1 day. Okay, clear. Then the state transition happens, and then the rest will be the same. So now I'm actually simulating everything by going through this event store. I'm not going through this internal thing. I'm not going through the back door anymore. But it's still a bit ugly because it didn't make the test smaller. It actually made it larger. Yes, I removed a lot of the plumbing and moved that to the base class because I really, and of course, there's only one test in this test case, but in real life, I've actually built systems like that. There will be lots of these tests because, yeah, there's lots of functional scenario, but it's still a bit ugly. So what I've done is test data builder. I showed you before, I use test data builder, which is one pattern in your test, but you also have object modders, which is another pattern. And again, it's not one or the other. No, it's and. Use them whenever that makes sense. So I use test data builders here, to build, have a flexible structure. Which framework allows me to write 1 January 2016? Yeah, that's Fluent Assertions. I didn't do that, by the way. You can do that here. That's a trick. But now I want to improve that. I'm going to use object models. What does it look like? Now, this is my test. Given a country was registered as, given a contract of kind in country was negotiated, given the contract was approved for a particular date. I'm doing the exact same thing here. The only thing is I try to make it really functional. It's almost BDD style. Like this, and the is technically just the same thing. It's just, to make it more functional. A country, not a specific one, a country was registered. Given a contract with this code was registered. And now I'm saying, yeah, but now I'm referring back to the one that was just registered, created here. And then in my when, I'm saying the contract is transitioned to active. And it's under the hood is doing exactly what I was doing before. And I don't want to go into too much details because we're already at the hour. But there's a bit of stuff here above that you can see how it works. It's just a bit of, you're building kind of your own little framework, almost like a domain-specific language to make your test more readable. You don't have to do it. But in our case, because we had an event source system, we were writing a lot of these tests. And then it makes sense to do something like that. And we didn't think of this upfront, we refactored towards that. So this part is already more functional. This part is still, So can we make it cleaner? I can try to. Now I have this. Does it fit in the screen? Almost. Now it fits in my screen. Everything else removed. Why do I still keep this really long thing? Because it's important for this test. It's the contract, you know, the contract of this unit, and that's how I designed it, is important. And the entry point is a URL. It has a certain route. So I keep showing that. The only difference now is that I actually created a special version of be equivalent to, in which I just pass in an object with a certain state, sorry, an object with certain properties, active and one. What it does everything that I used to do before, deserializing it, the JSON into an object with this structure. And notice, by the way, if you go back to the previous one, I already did it here. Here, I probably, oh no, I already did that. What you'll find is here, I was still testing a lot of properties, but I realized that for this particular test case, I don't care about country and country code and kind. That's a different test. This is specifically about the active count, and that's why it's so important to keep it functional. So in this case, I only say it should be an object, should be deserializable from JSON, and the only thing I care about, the state should be active, and the count should be 1. That's the rest. So in the final version, you just do this. And this method is just an extension on Fluent Assertions, which is part of this code base. You can look at the code base later on. That does exactly that. Everything else is removed from the picture, so it's kind of functional. You could say, don't use this little chill here. Maybe it's even smaller. Probably, we can try. And that's the whole thing. Every time I look at this test, I make it smaller. I hope that makes sense. Any questions in the meantime? Somebody's saying, could it be much more simpler in repository than for CQS? A repository pattern is a nice way, but the thing is, it abstracts the database layer. And that would mean I could create a repository layer between projections and RavenB, but then I'm skipping this part, which also needs to be tested. And then you're back to the part where you say, I'm testing this separately, I'm testing that separately. I think this whole thing, I mean, even the fact that I'm using RavenB may change over time because it's not fast enough, or maybe projecting to a JSON in memory what might be fast enough. I don't need some persistency here, but it may not actually change this entry point and this observable behavior. So this brings me down to some of the basic things, already refactored, is you really need to think about the scope of your tests. What do you want to test? Is it the individual unit? Is the group of classes? Do these classes actually work together? My rule of thumb, and it's more like a heuristic than a rule, if these classes are supposed to use together and those classes are not used by other parts, so they're actually part of a bigger thing, I tend to test the bigger thing as a unit. Sometimes that is not enough. Sometimes you actually need to test some internal details, because otherwise your bigger scope test, you will have too many permutations. That's fine. You know, you could have say, I'm testing the whole unit, but I also have a couple of specific tests that go much more in detail, which is completely okay. There's not one way of doing it. Remember, you know, the onions and the layers, that's what's here. So choose the appropriate type of testing. Unit testing is okay. Testing on the API level, on the component level, or even on the UI level, it's all important, and you need to test the which parts of the system you want to test with which kind of test case. Which parts of the system you want to test with which kind of test approaches. Then think about the boundaries. What is your unit, as you should show me? Could be a class if you really want to apply things like repository patterns. It could also be bigger, as I showed you here. This is really important, which has nothing to do with TDD, but if you do it wrong, you may feel like TDD is hard, but test-driven development is not that hard. It's writing really well-factored unit tests that's hard. Write your test in an intention-revealing way, and that's what I try to show you. Hide the things which are not important, have clear functional names, make sure that when the test fails, it fails clearly. You know, you get good output. That's why you can use libraries like Fluent Assertions and Shootly. But make it clear, make it obvious for the person that reads the code what this test is supposed to do. I wrote a blog post about it at some point, that if I look at if I have to review a code base, I first look at the test. I look at the functional name to understand what is this thing supposed to test in a functional way. Then I look at the implementation of the test. Like, does it actually do that? How does it actually verify this? Does it make sense? And only then I look at the underlying implementation, because not only if a test fails, it helps me understand if it's the test that was wrong. That happens quite a lot. Was the test actually doing what it's supposed to do? Before I want to understand the production. But if I do code reviews, the functional description also makes me think almost like the person that wrote the tests. Like, okay, given this scenario, is this what I expect this pull request to actually do or to achieve? And given this particular test scenario, what other things would I expect? Did the developer actually think of the edge cases? So that goes both ways. If you would look at the unit tests of Fluent Assertions as a library, for me, their documentation, that's also the promise of TDD. I often go to, if I get a question on Slack or Twitter or somewhere else, I often look at my own unit tests to understand, okay, how is this thing supposed to work? What's the expected output, or which API do I actually make available for developers? So for me, that's really true. And that's why the intention, in fact, I would say, and it's not, I think so, it's really true, your tests are first-class citizens of your code base. They should be reviewed and understood and written with certain quality standards just as well as your production code. So if you use ESLint because you write JavaScript or TypeScript code, you should also use ESLint to verify your jest or Jasmine tests. The same thing applies. Same on the .NET space. We use SonarQube, and the SonarQube rules equally apply to the unit tests, because unit tests are really important. Sorry, not just unit tests, all your tests. They're first-class citizens of your code base. And finally, try to avoid dry, because dry leads you in a situation where people start to refactor things for the wrong reason. Only refactor things because you see that multiple test cases have things in there that are not important for the test. As I said before, I have a base class here, but I only decided to do that because every test case I have was doing the same thing. And I literally do that. I copy paste my test a couple of times. I just write out the whole thing, copy paste a couple of times, and then I try to see if there's a pattern. And if that pattern exists, I refactor, but not before that. And I do that, by the way, everywhere. I only apply dry when I've seen the pattern. Otherwise, you end up with overzealous application of layers, generic code that is not really supposed to be generic. Be careful with it. Dry is a good thing, but within the boundaries. I think that's the end. Yeah, if you have more questions, obviously you can ping me at my Twitter handler, or you can send me emails, and we can still answer some questions right now. So I'll stop sharing my screen so I can see people, and if there's questions, we can have them right now.
Yeah, cool. Well, obviously I'll leave the applause for in a minute, man. But that was really good. I think we had the most. I think we had about 85 people, and yeah, a lot of people stayed to the end. So yeah, I hope everyone's enjoyed that. There were a few questions which I picked up, which weren't read out throughout the session. So if I read them out now. So the first one was from Bas. He said, what are your go-to libraries for testing in a new .NET project, apart from XUnit/NUnit/Fluent Assertions, of course?
Indeed, definitely XUnit, which is my preference. I don't have any experience with NUnit, not in the last couple of years. XUnit, Fluent Assertions, obviously. If I have to use mocking libraries, I typically use Fake It Easy, which is the one that I prefer a lot. What else? Autofixture, indeed, I've used it as well. Especially if I create the more behavior orchestrational tests, I indeed use Chill. Not because I created it, because I didn't create it myself. Somebody else created it, but I like it. But not always. Yeah, mSubstitute. I have not used that much. I heard good things about it. Yeah, it's more like I used something in the past, I stuck to it. Machine specification, same thing. I've spoken to many people that tried to convince me to move to smooth to something else. I didn't really need it, but I guess they serve the same purpose.
And then one more from Bas as well. He mentioned, do you have any recommended best practices for naming your tests?
It's interesting. There's many different ways of doing it. You can clearly see what I'm doing here. I use the, the when blah blah, it should blah blah. I like that. I really don't like. I know Roy Osheroff once promoted something in his book. What was it called? It's an old book. I don't even remember. The Art of Unit Testing. This like class name and some concept with an underscore. I don't really like that. I do like underscores, but I like to keep it more functional. And if it's an AEA thing, I use the when, it should, that kind of thing. If it's a more like a BDD thing, I try to use the given when then construct. But functional for me is important. Yeah.
And then there was one from Eddie. I'm not sure if it was answered or not. But this was, what are your views on something like auto fixture to
Yeah, I
build
answer
test
that.
data? You
Yeah,
did.
I answer that. Yeah, yeah. It's great, and you can combine test data builders with auto fixtures quite well, especially with more complicated code bases. Yeah.
Okay. Well, I think that was pretty much it because you're answering it as they came in. I mean, there's been hundreds, literally, of comments throughout the session. But if anyone else has anything now, of course, Dennis is. Oh, here we go. Here's one from Ravi. How do you set your mindset for the test first for already written projects? Yeah.
That's a really good question. Um, so the thing is, doing test first is quite difficult. No, let me rephrase it. Adding unit test or testing to an existing code base can be quite hard, especially if that code base wasn't designed for that. I mean, that's one of the promises, and it's true. TDD will force you to design your code in a more testable way by thinking about the boundaries, being able to fake out or mock out certain dependencies. For existing code base, that can be hard, but Michael Fadders has a book called, I think it's called Working Effectively with Legacy Code Bases, where he talks about characteristics tests. And characteristic tests are a great way to say, I'm going to create a bunch of ugly tests that cover the whole thing, including all the underlying I/O and databases. And the only reason I create those tests to create a kind of safety net. So the test basically just rerun what the current behavior is. That's why they say it's characteristic test. They are tests that try to characterize or cover the characterization of the existing code base. So you cover that. The link is just being shared by Jaspio. Thank you for that. So you're essentially trying to create a safety net around your existing legacy code base, and then you start to refactor, create seams, create more focused unit tests up to the point that you can remove the characteristic test because they no longer need it. So in a sense, you create a little safety net so that you can refactor the internals, make things more testable until you get to the point that you can really add new logic by creating a test first. And that's quite often very difficult. But I've done it myself. It looks weird to create ugly tests, but they really are supposed to be thrown away at some point. But it helps because for me, it's like, I don't know if many people have cars these days anymore, but driving without seat belts, you know, I don't want to test code without my tests. So I don't want to change code or refactor it without my test cases because it gives me a nice secure feeling that what I'm doing didn't break anything. I mean, even Fluent Assertions, which is pretty simple library, we have 16,000 tests because there's so many different things you can do. It gives me a good feeling if I touch something, it doesn't break anything. It's no guarantee, it never is, because you need a good QA, which is the people that use my library, that test my library often, but it's a good starting point.
Okay. Then, yes, I think we were right. This was one at the very beginning. I think you said you were going to circle around to the end.
Yeah.
The question is, what/who are you testing for? What's the purpose? Helps prove to your client about overheard of writing tests themselves.
Yeah, that's it's a question you get often. How do you start doing this and convince your management that this is a useful thing? Ideally, you don't, because it's just part of your development effort. But I know with growing teams where the The team lead is often also the CEO. Um, Without it, how are you going to guarantee that the thing just works? You can't. You probably suffer from a lot of bugs. You fix something here, and then something else breaks there. It's just a way of doing it. Um, it obviously costs a little bit more time, but you're always going to earn it back. It also makes sure by practicing TDD, as I said before, that you design your code in a better way. You can go overboard with that. There's people that really hate TDD because they hate all these small unit tests. That's just a result of testing too small. But yeah, it's. I mean, I think the analogy. I think the book Clean Coder from Robert C. Martin, not Clean Code, but the other one, talks about that. It's really weird to have to explain to your manager why you want to do your job correctly. But I realize it sometimes this happens. It's really difficult to explain to somebody who is not actually doing the work. I would just go in stealth mode and gradually start doing it myself without telling your manager. And just showing, you could even do it on a small piece of code, the new stuff, you do it correctly. And then you'll probably figure out that the new code is much easier to maintain, but also much more reliable. Bugs don't reappear every time. And it forces you to ask questions because, yeah, you will create something and suddenly you discover that by writing the test, you get much more questions for yourself, which you're going to ask your product owner. And then your product owner starts to wonder, since when did my developers think so well about my functionality? And then you can say, yeah, it's because we create tests first. It forces us to think about that. Again, it's in real life, it's never going to be as simple, as beautiful as I just said. But yeah, that's what I can say about it.
Well, yeah, the chat has kind of blown up recently because I think Tim asked something about how do you convince stakeholders slash product managers that we as developers need time up front to create automated tests. I think a few people jumped in and gave their thoughts on their behalves.
My professional answer is a product owner has nothing to say about how you design your code. It's a practice of a team. But okay, I know that there's going to be questions. Why does it take 5 story points now? It's just adding one line. That's that's a typical discussion. I see some people laughing, so I know that's happens like that. Yeah. Indeed, factor, don't tell them and just say it's 5 points. Why? Because it is. It's really complicated code. You're asking us the impossible. Okay.
Okay. Well, yeah, I'm trying to think if there's any more in here which we've kind of not answered. But yeah, I mean, as you said earlier on in the session, we can get you on pretty much all your handles, but definitely Twitter on Doomen.
Yeah.
I know you're always happy to come back to people on LinkedIn and Twitter.
Absolutely.
So yeah, are these slides? I mean, of course, we're going to be posting this up on YouTube, but are these slides going to be available after the session?
Cool.
Yeah.
I will. And the code is somebody already shared the link where you can find the code and look at that and investigate some of the patterns. By the way, in the slide deck, there's also a slide with a bunch of resources, links to useful articles. So when you have access to the slides, the rest will be there as well. I'll put them to SlideShare as well. Cool.
Well, yeah, thanks everyone. That was one of the best ones, I think. I mean, we've had a lot of people stay to the end. So as I mentioned, the next event is in exactly 2 weeks' time from today, where we have Dylan Beatty, the guy with the black hat, is going to be talking about plain text or the lack thereof. And then after that, the event which I announced at the beginning of the week on .NET Core AI and a Raspberry Pi. So yeah, stay tuned. We've got loads more in the pipeline. I think there's about 3 more events which I'm sat on, which I'm yet to put out. So obviously, stay subs. I'll see you in the next one. And yeah, thanks again, Dennis. That was great.
It was an honor to be here. Thank you for organizing it, and thank you everybody for joining. Happy to see so many happy people here.
Okay, I see people waving. All right, cheers, guys. See you the next one.
Have a nice evening. Bye, guys.
Bye.